Taylor polynomial for cosine centered at x equals 0. And so remember, in general, this was what our nth degree polynomial was looking like. So let's look at that with some other functions besides just cosine. So the first thing that we're going to look at is just given in function notation. So it says that suppose f is a function which has continuous derivatives, and that f of 2 equals 1, f prime of 2 is negative 3, f double prime of 2, don't know why there's a colon there, equals 5, and f triple prime of 2 equals negative 7. Write the Taylor polynomial of degree 3 for f centered at c equals 2. So how many terms is my polynomial going to have? Close. 4, right? Because we start at a degree of 0 technically, right? Because we start at f of whatever the c value is, so we start at a constant, right? So we'll have a constant, and then we add each of our derivatives after that. So we will have 4 terms. Okay? Are we all right with that? Alright. So let's build it out. I'm just gonna apply the formula straight up first without plugging in values, just so that we practice what our formula looks like. Okay? So what is our first thing that we have there then? F of c. Okay? And in this case it does give us that our c value is what? 2. So I'm gonna have f of 2, then what? Plus f prime of 2 divided by what? It is a factorial, but this is my first, so it's technically 1 factorial, right? Okay. This is why we're practicing the formula. Plus, then it's my, then times what? X minus our c value plus f double prime of 2 divided by 2 factorial times x minus 2 squared this time. So basically, remember that your nth degree derivative should match your nth power and the n factorial on the bottom. They should all match. Okay? I'm just out of room, so I'm going to put it just down below. And then what's our next term? F triple prime of 2 divided by 3 factorial times x minus 2 to the 3rd. Now, as always, okay, remember that if something is just numerical to evaluate it, okay, you don't have to technically do that part for a free response question, okay? Which, what I mean by that is, which in this case is not a big deal for 1 or 2, but we could leave it at 3 factorial if this was a non-calculator active question. We don't actually have to evaluate the 3 factorial. Does that make sense? Yeah. Especially if you go higher than that, like 4 factorial, 5 factorial, you're not expected to just know those, so I would just leave them. Unless it's calculator active, then you can go ahead and plug that into your calculator. But what is f of 2? 1. And then prime of 2. Negative 3. And then 1 factorial is just going to be 1. So technically I just have minus 3 here times x minus 2. And then plus, what's our second derivative of 2? I divided by 2 factorial is 2 times x minus 2 quantity squared our third degree Taylor polynomial. What questions do we have? And the reason why I ask about terms is because technically if the directions could say write a Taylor polynomial with 4 terms, okay? But that would technically mean that I'm looking for the third degree in this case. Are y'all with me there? However, let's go back a bit. What would happen if I asked you to find, so instead of saying a 6th degree, what if I said a Taylor polynomial approximation for cosine with 4 terms? What would I have to go out to?
The third derivative.
Is it? 4. What's the issue with this one though? What's happening to every other term?
Oh.
Right? They go away. So I would technically, so 1, 2, 3, 4, I would have to get the 6th degree approximation here because that's what's going to give me 4 terms. So sine and cosine are both going to be like that. And we're going to look at sine in just a second. But if you had another function where like something's going away every other time, and it specifically asks for 4 terms or however many terms, you might have to go further to make sure that you actually get that number of terms. Does that make sense?
Yes.
But you can count as long as your constant is an actual number, right? And that's not 0. That counts as a term as well. Are we all with me there? Which is why I was just going over the clarification there. But that would be our answer for that. Alright, so this one says find the 7th degree Maclaurin polynomial for f of x equals sine of x. We centered at here?
0.
0, because it tells us that we are a Maclaurin. So what do we start with?
Sine of x.
Yeah, so it's my f. So f of x equals sine of x. What do we have to go out to?
7.
The 7th. But remember, it's gonna after a while, what starts to happen?
Pattern.
It's gonna be a pattern, so we really aren't gonna have to think that hard about it. What is our first derivative? Cosine. What is our second derivative? And our third derivative?
Negative cosine.
And our fourth derivative? 9. So then what's going to happen after that point? It keeps repeating. So then I'm just going to be cosine of x. Yeah, we're going to have to for my 6. Why do you think this time it asked us to go out to the 7th instead of the 6th like I did with cosine?
Because the parts that equal 0 are different on sine versus cosine.
Yeah. We all agree with that. And so notice that the things that went away for my cosine of x were all of the what degrees? No, I was only left with the evens, right? All the odds went away. Agreed? Okay. And that's because cosine is an even function versus sine is an odd function. So thinking of the same idea, most likely, which it will, all of our even ones are going to go away this time. So if I wanted to find then f of 0, what do I get there? 0. Okay, f prime of 0 is f double prime of 0 is 0. F triple prime of 0 is -1. The fourth derivative of f at 0 is 0 again, yes. The fifth derivative is 1. Sixth derivative and our seventh. Yeah, okay with that. Yes, no, maybe?
Is it just a coincidence that this like lines up with the graph of sine or cosine?
What do you mean lines up with?
Because they also go 0, 1, 0, and 1.
No, not necessarily, because again, remember we're trying to match it. So the farther that we go out, right, I'm trying to match as many of those mins and maxes as I can. So, no, it is not a coincidence. Either it's going to be exact, which in this case it is, because like that's how sine and cosine are, or it's going to be values that are really close. Like if we got like 0.9, -0.9, or something like that. Because again, this is an approximation, but it is going to be a pretty good approximation. But also think about your derivatives give you what on a graph? Relative mins and maxes, right? And so for this, for sine and cosine, right, your relative mins and maxes are those highs and lows. And so that's why we are going to be getting that negative ones and ones. So, we're looking at our P sub 7 this time. Yes, anybody? Okay, what's going to happen to our first term? Goes away, right? F of 0 is 0, so it's just going to be 0. So I don't have a constant this time, but that's okay. So plus, it's going to be, instead of x minus c's, what are they all going to be this time? Just x's, right? Because they're all x minus 0 because we're centered at 0 this time. So what do I get for my first term? Just x? Right? Because it would be 1 divided by, I'll go ahead and write it out. 1 divided by 1 factorial times x to the first power. Yes? Okay, you don't have to write that out if you're asked like this in a question, but especially while we're just like practicing the formula, I'm going to go ahead. Then what's going to happen to our next term though? My second derivative is what?
Oh, it will also go
0, right? So it'll go away. So then I'm looking at my third derivative. So I have plus, it's -1 divided by 2 factorial times x squared. Not x squared, x. I didn't skip my part. There. Again, skipping my fourth, so I have the fifth. Skipping our sixth and going to our seventh. Yeah. And if we did simplify that, we're going to get x minus 1/6 to the third plus 1 over 120 x to the fifth minus 1 over 5,040 x to the seventh. Bad luck. This owed me. What questions do we have on that one? we have to do here then is we're going to take what we looked at before with our cosine, and we are now going to see if we can come up with a general formula. Are we okay with that? Definitely.
Yes.
Okay. So I'm just gonna rewrite what our first few terms look like. So remember, I had 1 minus x squared divided by 2 factorial plus x to the 4th divided by 4 factorial minus x to the 6th divided by 6 factorial. Yes? Okay, which is what we got. Okay, I was just rewriting because I don't have it on my slides or up right now. So this is one of the reasons why when we did sequences and series last chapter, we practiced writing out formulas from patterns, because now we have to be able to write out a general formula for these numbers. So what's the first thing that's going to be pretty easy to tackle?
Factorial.
Okay. What's happening with our signs?
Oh, it's changing.
They're alternating, right? So I have to have n -1 to the, is it just n?
N plus 1.
You have to decide which one it is, right? So if it was just n, right, that would mean that all of my odds would be negative and all of our evens would be positive. Is that the case? Okay.
So that would be n plus 1, and it would make every other term instead of every first term.
Okay, I see what's happening. So again, how did I define our constant? So this is gonna be a little bit different than what we just talked about. How did I define our constant? I defined it as a degree of what? 0, right? When we were talking about how many terms I needed. Are we all with me there? So instead of, remember we have two options. We're allowed to start at n equals 1, which is I think where y'all were starting. Or we're also allowed to start at n equals 0, which is technically what's happening here, because remember these were my n's, right? And so n equals 0 on my first term. So when we're looking for our general form, okay, we're starting at n equals 0. Are we okay with that now?
Yes.
So now, does -1 to the n power match what we're getting there? Yes. Okay. Had to think through what y'all were saying and try to connect it back to what we were talking about. Okay. So then, again, even though, and again, this is going to take a little bit of shifting as well. Even though here I then plugged in the second derivative, the fourth derivative, and so forth, right? Those are still only the first term, the second term, the third term in this series, yes? So now we're treating them as the 0th term, first, second, third, and so forth, okay? Not as the derivatives themselves. So once I've come up with my additions and subtractions, I need to switch back to thinking about them in terms of a series. Are we with me there? Okay. Because otherwise we would never have n. We would have to do every other n, which we don't have a way to do that with a series. I have to plug in every single integer. Are you with me there? Okay. So then I have x's on top. Yes?
Yes.
How would I rate my power out for that?
N plus 1. Wait, n squared.
N? What is it? Just times 2.
Oh, yeah.
Because if the first one is to the 0th power, right? 2 times 0 is still 0. That's why I don't have an x there. Yeah. Which is also why we need to start at n equals 0. then yes, we have factorials going on underneath. What do those also happen to be? Not just n factorial, 2n factorial. Because again, now we're skipping every other one.
And that's why we start with 0, so we don't have to put like n minus 1.
Yeah, it would be kind of something funky because we don't have an x on our first one, which is why we started it. Yes, little baby. Okay. You need to know this. The general formula for your Maclaurin of cosine. We also happen, and I think I talked about it yesterday, we also need to know the general formula for e to the x and sine of x, which we're going to talk about next. So speaking of, write the nth degree Maclaurin polynomial for f of x equals e to the x. Now this one we didn't do is actually way easier, guys. Because let's think about this. What's f of x? Oh, I'm just writing. You're fine. Do we have it written down now? Okay. My original function is e to the x. What's the derivative of e to the x? What's the derivative of that e to the x? What's the derivative of that e to the x? Super hard, right? Alright, so now if I plug in 0, okay, because I am again looking at a Maclaurin, so centered at 0. What is f of 0? What is f prime of 0? What is f double prime of 0? What's gonna happen? They're all gonna be 1, right? We actually like to do this. Pretty nice. So, let's start writing those out, kind of like we did with the last one, right? Because then it's a little bit easier to see the pattern if we write them out. So, I would start with 1 plus...
Yes.
Oh man, that's fast. Alright, we'll finish up tomorrow. Like I said, this one goes really fast. And then sine of x will work very similarly to our...
Would it just be like a different?
It's going to be odds instead of evens, basically.
So it would have to be like